This video is going to be for solving basic equations. So our basic equations are going to be in a form something like this, where we have a polynomial on one side set it equal to 0. Of course, we're just going to start with just second degree polynomials, but you can have much larger ones, and we'll talk about that later. But this is going to be pretty similar to the factoring video. So let's start out with one here. Let's say x squared minus 7x plus 10 equal to 0. So if you haven't watched any of the factoring videos, there's a couple of videos about how to factor this. So I'm going to give you a couple seconds here. You can pause the video and factor this, and then we'll move on. Okay, I hope you got it. If not, pause it and try and get it now. So whenever you factor this, you factor it into this form here. Okay, so we're still set equal to 0. So what we want to do now is we actually want to solve it. We want to find out what x equals. So the way we do that is we're going to set both of these two things equal to 0. So we say x minus 2 equals 0, x minus 5 equals 0. So we add the 2 to both sides. X equals 2. Add the 5 to both sides. X equals 5. So this is what we have as our two solutions for this. And we'll talk later, especially in the more advanced version of this, how these are actually solutions. But one way that you can check this is you want to plug these back into this problem for x here and x here. So let's do that. We'll say 2 squared minus 7 times 2 plus 10. That's going to equal 4 minus 14 plus 10, which if you add the 4 and the 10, you get negative 14 plus 14. So that does in fact equal 0, so we're good there. So now we'll try this 5, and we'll do this up here. So we'll say 5 squared minus 7 times 5 plus 10. We want it to equal 0, so we're going to work on this left side. So we'll say 25 minus 35 plus 10. So we'll say 35 minus 35, get 0 equals 0. So those both work out, so that means those are both solutions for this problem. So let's move on to another one. Okay, so our next one, let's do x squared minus 6x minus 27 equals 0. So pretty similar. Pause the video and try and factor this. Hopefully you got x plus 3 times x minus 9. So same thing, we set both of them equal because it's still equal to 0. So we say x plus 3 equals 0, x minus 9 equals 0. Solve for x on both of them, so minus 3 plus 9 plus 9. X equals negative 3. X equals positive 9. So now what we're going to do is we're going to plug them both in. So we'll start with negative 3. So we'll say negative 3 squared. It's a good idea to have your parentheses here. Negative 6 times negative 3 minus 27. So this negative 3 squared is going to give us a positive 9. Negative 6 times negative 3 is a positive 18 minus 27. That gives us 27 minus 27, of course, equals 0, which is what we wanted. And then we'll do 9, so we'll say 9 squared minus 6 times 9 minus 27 is going to give us 81 minus 54 minus 27. We want to get that to equal 0, so we're going to get 81 minus 81, and of course that gives us 0 equals 0. So that's what we wanted on that. So here's a slightly more difficult one. Let's say 2x squared minus x minus 21, and of course equal to 0. So you're going to factor this. Hopefully you got 2x minus 7, x plus 3 equal to 0. 2x minus 7 equal to 0. X plus 3 equal to 0. So this one we're going to add the 7 to both sides. 2x equals 7. Divide the 2. X equals 7/2. Subtract the 3 from both sides. X equals negative 3. Okay, I assume you can plug in this negative 3, so let's work on this 7/2, plugging this one in. So we're going to say 2 times 7/2 squared minus 7/2 minus 21 equal to 0. So that's what we want to solve. So let's take this 7/2 squared up here. Make sure we remember how to do this. So whenever you got a fraction squared, you're going to apply that square to both of them. So you're going to get 49 over 4. So now we have 2 times 49 over 4 minus 7/2 minus 21. Okay, now what we're going to do, let me zoom out a little bit. Now what we want to do is we can reduce this right here because we got this 2 and the 4, and technically this is 2 over 1. So this can become a 1 and that can become a 2. Make sure you've done that correctly. You say 2 times 1 is 2, 2 times 2 is 4, so that works out. So now we have 49 over 2 minus 7 over 2 minus 21. We want this to equal 0. So right here we have common denominators of 2. So that means we just subtract the top part, or the numerator. So we get 42 over 2 minus 21. 42 over 2 is going to reduce. This will become 1, and then we'll divide 42 by 2, which is technically what that is. So we get 21 over 1, which is the same thing as 21. So we get 21 minus 21 equals 0. So that means it works out. You'll want to go back and make sure this x minus 3 does that, but it's pretty obvious that it's going to work out that way. Let's do another one. So this one's of a little bit different form. It doesn't have our bx, and this is going to be a different way to factor. Be a video about special ways to factor, especially if you have something that's in the form of a squared minus b squared. So in this case we would say this is x squared minus 3 squared. So you want to get to where you can recognize our perfect squares here. So what that means is this is a way that's always going to work. A minus b times a plus b. So in this case, if our a is x and our b is 3, so a minus 3, and of course a is x, and then a or x plus 3. So what we do to solve this one, we're going to work it the same way we did the earlier ones, to say x minus 3 equals 0, x plus 3 equals 0, so x equals 0, or excuse me, x equals positive 3, x equals negative 3. You test it the same way. You just plug your positive 3 and your negative 3 back into our function up here, and we work it out and make sure it works. So let's do one final example. So in this final example, this will be one that we have to do with a quadratic formula. So let's say, and this is going to be the same example that's in the quadratic formula video. We're just going to have this one set equal to 0. I'm going to show you, and we talked about this in the quadratic formula video, but this will just kind of show that again. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this one, I'm just going to plug it in, and then I'll get to the answer for it. So it's going to be a negative 7 plus or minus the square root of 7 squared minus 4 times a, which is 2, times c, which is 21, all over 2 times 2. And if you don't remember, or if you haven't watched that video, of course our a corresponds to what's in front of the x squared, b is what's in front of the x, c is the last one. So that's how we just plugged them in. So we said negative 7 because 7 is our b. If it helps, you can go over here and list these things out. You can say a equals 2, b equals 7, c equals negative 21. If that helps you plug them in, obviously you don't have to always do that. So the main thing I want to show here is that x equals this. That's what the quadratic formula is saying. So it's saying x equals, and I'm just going to go ahead and write out what it equals. It equals negative 7 plus or minus the square root of 217 over 4. Now you have two answers here. You have negative 7 plus 217 over 4. And you also have negative 7 minus 217 over 4. And we'll talk about this in another video, but that's because you have a squared here, so you're going to get two separate answers for that. Now there are some variations where you talk about multiplicity of it, but we'll talk about that in a later video. But for the most part, you're going to get two separate answers for a second degree polynomial, which is what we have here. But the good part about this is we don't have to set it equal to 0 because it already was x equals. So x actually equals these two things. Now you could plug these back in to this problem here, but that would take a while, so you don't necessarily have to do that. But that's how you solve equations. Like I said, this is the basic version of it. We'll do some later where x is not just x squared, maybe x to the 5th or x to the 6th or something larger than that.